Hello, my name is Amashni. In this lesson, we are going to look at how your knowledge of triangles relates to other geometrical properties. But before we begin this investigation into these properties, there are a few terms that you would need to know. The first term is a transversal. A transversal is a line that intersects two or more other lines on a plane. This transversal has a special relationship with three different types of angles. The first type of angles that we find are called corresponding angles. They are found on the same side of the transversal as well as on the same side of the lines that the transversal intersects with. The second type of angle is called alternate angles. These angles are always opposite of the transversal and on the inside of the lines that the transversal intersects with. Our third type of angle is called co-interior angles. Do you notice that they are always on the same side of the transversal and on the inside of the two lines that the transversal intersects with? These are very important angles for you to remember, and we will refer back to them a little later in the lesson. Now, to understand the relationship between triangles and geometrical properties, we will need a diagram. Do you remember that in the previous lesson we asked some learners to translate triangles along a path to form a triangular grid pattern? Well, I have brought that triangular grid pattern that they constructed into studio today to help us in this lesson. There are a few important things I need you to remember about this grid. The first is we used a straight line and we marked it AB. We used this straight line to translate our triangles. Then we used another straight line DF to continue the pattern. Then we used FH to continue the next row of translated triangles. You should also remember that we carefully translated the angle markings so that we could keep track of the size of the angles. The reason I am reminding you of this is that it is important for you to understand that to complete this grid pattern, we had to use three different sets of straight lines that follow three different directions. Here is a graphic image of our grid. Notice the different directions of the three sets of lines as we highlight them. Within this diagram, there are two patterns that I would like to point out to you. When we look at a saw that a carpenter would use, we see that the edge of the saw has teeth. Do you see that these teeth have angles that look as if it is the same size? Now look at the pattern that I highlighted on trace paper in our diagram. Do you notice that they look very much like the teeth of a saw? And if you look at the angle markings, you actually see that the angles are equal. There are different ways in which the saw pattern is visible in the structure. Have a look. And here. I would like to examine the saw pattern in a more geometrical way. Let's use the trace that I just showed you. I have marked the angles in a different way, but you should still be able to see the markings from the original diagram. We can see from the way we translated our triangles that K1 is equal to E3 is equal to L1, F3 and M1. You can clearly see this by the symbols being the same. If you think back to the types of angles we looked at in the beginning of the lesson, can you see that we can also call the angles that we have just identified alternate angles? In this diagram, LF is the transversal. We see that the two angles that are equal to each other lie on opposite sides of the transversal. They also lie on the inside of the two lines that the transversal intersects with. Now we know from a previous lesson that when we translated these triangles, we used a ruler. So we know that EL and FM are straight lines. Now have a look. We see that EL is parallel to FM. This conclusion brings us to our first very important relationship. We can now say that if a transversal cuts two lines and the alternate angles are equal, then the two lines are parallel. The next pattern I want you to look for is also found in a hardware store. Take a careful look at the pattern that is outlined by the colored lines. Doesn't it look like the steps of a ladder? If you look carefully at this ladder, you should see that the steps are equal distances from one another. You should see that the same is true of our pattern. Now the angle markings show here a circle and a rectangle. And if we look at this angle, we have a circle and a rectangle. So we can see that this whole angle is equal to this whole angle, and here we have a circle and a rectangle again. So this is also equal to this angle and this angle. You notice also that this whole angle is equal to this whole angle is equal to this whole angle. There are many different ways to see the ladder pattern in this structure. Next, we are going to investigate the ladder pattern a little more closely. If we think back to the angles that we identified at the beginning of the lesson, you should be able to see that all of these angles can also be called corresponding angles. In our diagram, DH is our transversal. Do you see that our equal angles E3 plus 2 and F3 plus 2 lie on the same side of the transversal? And they also lie above the lines that the transversal intersects with. Based on what you have observed, can you predict the next important relationship? We can now say that if a transversal cuts two lines and the corresponding angles are equal, the two lines are parallel. The angle markings of H2 and 3 show that this whole angle is equal to F2 plus 3. Now they are corresponding, and because they are corresponding and equal, FM and HN should be parallel. Let's check this with our ruler and set square. Yes, they are parallel. So congratulations if you got that right. Now we need to investigate our third relationship. But before we do that, we need to refresh our memories on what we know about the angles on a straight line. We know that the angles on a straight line at a point adds up to 180 degrees. Now we have used a square, circle, and a rectangle to represent this. We say that the square plus the circle plus the rectangle is equal to 180 degrees. But if you look here, we also have a square, circle, and a rectangle. The same is true here. We have a square, circle, and a rectangle. Do you agree that we can conclude that the sum of these angles is also 180 degrees? You should remember that we can also call these angles co-interior angles. So here they are again. Once again, I've used trace paper to highlight the angles that we will be working with. Now EF is the transversal. Do you see that the angles lie on the same side of the transversal, and they lie on the inside of the two lines the transversal intersects with? From this information, we can now formulate our third relationship. We can now say that if a transversal cuts two lines and the co-interior angles add up to 180 degrees, the two lines are parallel. The three relationships that we have discussed today are very important, so have a look at them carefully as we recap. We found that if a transversal cuts two lines and the alternate angles are equal, then the two lines are parallel. If a transversal cuts two lines and the corresponding angles are equal, the two lines are parallel. And if a transversal cuts two lines and the co-interior angles add up to 180 degrees, the two lines are parallel. Thank you for joining me in today's lesson.